I'd like to introduce you to Liran Cohen. He's a co-founder and CTO at Sosivio. He is a Kubernetes master, open source enthusiast. He's done everything from networking and security and IT and developing, and he's done it all. So Kubernetes is his latest best friend, I'll say. He's got a lot to share with you. Every other week we do these office hours, and it's a different topic every other week. This week the topic is liveness, readiness, and startup probes. So join us for the next one, and we'll share at the end what the topic for the next one is. And if you find it useful, please invite others to join us as well. We will also be sharing the recordings of these online on our YouTube channel. So if you think this will be useful to any of your other Kubernetes friends, please pass it along and get them to join us every other week. We did have an issue last week, a technical difficulty with internet. So we moved last week's to this week, and we will be back on schedule with next week's on the 8th. Last thing here, just some rules. If you have any questions, we are going to be using the chat feature. So please send your questions. And as we're going, you can send them. We're going to go chunk by chunk and pause for breaks for questions. And at the end, we'll save a significant amount of time for question and answer. But again, if you have a question, please send it to the chat and we will address it. And lastly, you'll see a little QR code on the bottom here. If you'd like to have a copy of this presentation that we're sharing today, scan the QR code and you'll have it for yourself. You'll own that document. So I'll pass it off to Liran. Turn my video off. You're not here to see me. And we'll catch back up with you at the very end of this session.
Okay, so hi everyone. As Adam said, we're going to talk today a little bit about liveness, readiness, and startup probes, which are all the types of probes that you can define in Kubernetes. We're going to talk about what the probes are, and from there we're going to go through and see why we need them. Basically, everybody knows, or who doesn't, Kubernetes basically is a way to maintain applications and run them, orchestrate them, see what needs to be restarted, what needs to be, when you roll out a new version, how do you roll out the version without damaging service continuity for users, etc., etc. So these probes actually give Kubernetes or the platform itself, it gives a lot of information as of whether the application is alive, ready, and started, as the name suggests. But there's a little bit more to it because it also involves the way that you actually plan your application. So we're going to be starting with what the probes are. So we have liveness, readiness, and the startup probes, the three probes that you can define for any pod. You actually define it not in the pod, but in the deployment. We're going to see it on the hands-on session in a couple of minutes. So the liveness actually makes sure that the application is live and running. That means basically not that it's ready to accept connections, not that it started, but it's alive. The process is alive. It's running and it's starting to do whatever it needs to do. Let's say you have to provision a database in the backend, or maybe you need a communication with some other third-party application before you can hand out connection or before you can actually operate as an application. So the liveness is a probe that we define to actually know that the process itself atomically is running. The readiness probe tells Kubernetes whether the application is ready to accept connections through the pod service. So in Kubernetes, communication is done when you connect to the service, and the service in turn connects you to the pod. If the readiness probe is down, then this connection between the service and the pod is disconnected. So the pod will not be available through the service. We're going to see that in a second. The startup probe is actually something new that came in, I think, in Kubernetes 1.2, and that came to augment or to complete the way Kubernetes probes applications. And I'll give a hands-on example in a couple of minutes, as I said. But mainly, the startup probe says, when do I start to check liveness and readiness probes, because some applications actually have warm-up time, for example. And if I check before the application is actually started, not even live, even started, I might fail the probe. And we're going to see the definitions for each and every probe and when do we fail it or when do we pass it. So as I said, why does Kubernetes needs these probes? Some applications actually don't need probes. When you run an application that instantiates immediately and is ready to accept connection, it's not dependent upon any other application or any other dependency, basically, then the need for probes lessens significantly. But most applications are not like that. Most applications actually depend on something, even a front end and a backend application. There's a tight dependency between them. The front end will not operate without the backend, and vice versa. And you need to actually tell Kubernetes or the platform itself how does your application behave and what it should expect when a probe succeeds or fails. And again, in order to keep service continuity, which is the most important thing in Kubernetes, right? You have a user, let's say you have a website, and the website does something for the user. You want this communication between the user and the website to be kept ongoing, continuously, not disturbed at all time. Also, one of the things that Kubernetes does very good is allow you to deploy a new version without disturbing users, meaning if you want to actually deploy a new version of your application or parts of your application, you can deploy it and the users using your website or whatever application you not feel anything happening while you roll out the new version. So without probes, there's a risk that you will deploy a new version, it will accept connections without being ready to actually service them to users. Every probe for now, for this version, currently has these three probes that you can actually define to it. A TCP probe actually runs a TCP connect, much like a telnet, but it only tests that it can connect. Meaning if you have an application that listens on port 8080, you can put a TCP probe. Once the application binds to port 8080 and is ready to communicate TCP-wise, the probe will succeed, basically. An HTTP probe, you can use it with headers or without headers. Without headers, it just accepts 200 or 300, which is redirects as true, meaning if your application has a web server inside, once it's ready on a specific port, the HTTP probe will probe that port. If the response, the HTTP code that comes back to the probe is 200 or 300 to a 200 or 301, 302, etc., the probe will succeed. If it's above 300, which is 400, all the page not found, forbidden, etc., it will fail, and 500, of course, server will also fail. And you can also use headers. So you can tell the probe, okay, so port 8080 is ready. I can give you a 200 okay, but something in the back end is not right. So I'm sending you this header to not actually pass this probe but fail it. And the last probe that you have is actually a command. You can run a command, and we're going to see that also. And check the command status, exit status. If the exit status is 0, meaning the command succeeded, any other exit status will fail the probe. These are the configurations that you can put. This is actually taken from the Kubernetes documentation, as you can see. I'm going to run through them in a second because we're going to see them and we're going to meddle with them a little bit in the deployment itself. Initial delays in seconds for each probe. I can say when to start testing that probe, when to start actually probing. So if my application takes, let's say, 20 seconds to just instantiate itself, I won't want to check before that because I know it's going to fail. So I can say, wait for 20 seconds before you start testing. Period in second, how often to actually run the test. So I can run the test after 10 seconds. If it fails, I can run it again in 1 second, or I can run it again in 5 seconds, or 7 seconds, or 10 seconds. So that's actually the period in which the probes are applied or actually tested. Timeout in seconds is how long should I wait for a response for whatever command that I ran, probe that I ran, either TCP, HTTP, or command. So if I'm trying to reach port 8080 and the timeout in seconds is 1 second, then I'm going to wait for 1 second. If I'm not going to get a reply, I'm going to fail the probe. Success threshold is actually how many times does the probe succeed, the test in the probe succeed before I can actually declare it as true, as the pod actually passed the probe. And the failure threshold is actually the opposite. How many times I'm allowing the probe to fail or the test to fail before I announce the probe failed. So what happens when we don't configure probes for a pod? Basically, when I'm not configuring the readiness probe, for example, or the liveness probe, from the Kubernetes point of view, whenever the container starts and it's running, then the process is ready to accept connections. So it will actually start sending, if it's in a running and a ready state, the Kubernetes will actually start sending requests through the service, if they come, directly to the pod, regardless of whether the pod is ready or not to accept connections. Maybe the database is not up yet. Maybe it has to provision a schema before that. Either case, the Kubernetes will start sending communication towards that pod. And we want to prevent that because, as I said, in situations, especially when you roll a new version or when you just delete one pod and you want to delete, let's say you have 2 pods, you want to delete one, wait for it to start back up again, and only then delete the second so as to not disturb the users. If you don't have any probes, you can kill the first one or terminate the first pod. It will start again, be running in ready state, start accepting connections. You will kill the second one, and there will be no communication towards the user platform or client, sorry. So the application design with probes in mind actually gives you the chance to externalize, or let's say instrument, if you will, into Kubernetes. How does your application behave? So you can create commands, you can create headers, as we spoke before. You can do basically a lot of things to notify Kubernetes how things work inside your application and when should it actually direct traffic towards it, when should it restart it, et cetera, et cetera. That also comes to the methodology or to chaos engineering, where you want your application to fail quickly if something is wrong. So in order to do that, you need Kubernetes to actually know when your application is misbehaving or not returning the desired output towards users. So this is, as I said, the short presentation. Being a terminal guy, I will now go to the terminal. Before that, I will show you a small application that we created. It's called the demo app. It looks like an e-commerce website where you can add things to the cart regardless. But what I want you to notice is actually the backend status here. Now the application now is deployed with Readiness Startup and Liveness Probe. And it's already been running for a while. Now, what I want you to see is what happens if I take these probes for the backend and completely comment them out. This is, by the way, this is the YAML that deploys this application. You can see that we have a backend and we have a front end here, which is the demo app itself. But I'm going to change only the backend. Let's say we just had a new version, which I already created an image for. It's version 116. And I'm going, you see, these are the pods that are running. These 4 pods are running. We have 2 front end, 2 back end pods. And of course, the application is running right now. Sorry. I'm going to apply the new YAML. And what's going to happen now is that Kubernetes is going to replace these 2 guys. But remember, they don't have any probe now. And my backend takes 120 seconds to warm up, meaning the process is up and running, but the application is not ready to accept connections for 120 seconds. So Kubernetes doesn't know that, right? So it's going to create the containers. Once the container is created and running from the Kubernetes perspective, it's ready to accept connections because I didn't tell him anything that indicates otherwise. So it's creating the first container. And we can see that it's still, okay, it's creating it. And it's running, it's in running state. Notice that the backend is still in an okay state. And now it killed the second one because guess what? It has 2 pods up and running now. These pods are terminating. This is why you see the okay here, because they are still responding to queries from the front end, from basically from my browser. And now you see we have 2 backend pods in running state. Everything looks fine. I rolled up the new version from Kubernetes. Everything looks okay, but my application is broken. I cannot do anything now. Now, it is going to be okay because after 120 seconds, these pods will be ready to actually accept connections. If we wait for it, I see that this one was created before. So in like 30 seconds, give or take, because it took time to instantiate the container, backend status is going to be back to okay because the process will be up and running and ready to accept connections. The second one will take some time basically afterwards and will also be running in running state. But what's important, the message that I'm trying to give right now is basically that I rolled out a new version, everything looks okay, but my application is actually broken. I cannot use, if this was a real website with users running in it, and I would just deploy this version, nothing would run. Users will not be able to purchase anything. They will not be able to browse the website. Basically, it's completely shut down until the pods instantiate. So the question remains, sorry, how can we prevent this or eliminate it completely? And you can see that the backend status is now okay. It took a little bit more because the container took time to instantiate. By the way, the okay that we see is basically the first one that could accept the connection, that finished the warm-up, started responding. So I had a backend running. The front ends are always running. They didn't change. They've been running for 40 minutes now. But the important thing is that basically I deployed a new version and I didn't have an application. The users suffered as a consequence. Now let's go back to version 115. And then I have these 3 probes that I've defined, right? And I want to show you guys why is it necessary to use all 3 probes, right? The whole session today is about that. So why couldn't I do something like this, for example? This probe actually is running a command. The command it's running, it's actually trying to get the process ID, the number behind the process that is called BE, backend. Okay, that's a process. Now, this BE is actually a binary that is running, and it's the backend of the whole application. It is going to be created 120 seconds after the pod starts. So what I did here is I gave it a failure threshold of 60, but it doesn't really matter because as long as this guy fails, these 2 will not start. But if I put only, let's say, the readiness probe, look what will happen. So I'm going to put the readiness probe, right? Because my intention is that no new pods will be started until the pod is ready. So I changed the version, just to recap, I changed the version back to 1.15 just to make the application deploy. And I uncommented only the readiness probe. Everything else is still commented out. So now we're going to deploy it again. And let's see what's going to happen now. My application is still running. I still have a backend running, right? It's okay. And now one new backend is trying to deploy itself. So the container is creating, it's pulling the image, it's going to start it, it started it, and now it's still not ready. You can see that 0 from 1 is ready. Why? Because it doesn't have a readiness, the readiness probe is failing. And we are going to see the consequence of why the readiness probe is failing. This pod will actually not be ready ever because it will fail, restart, and restart again. Let's wait for it. It's still trying to start.
This is a good chance to pause for a sec and make sure we don't have any questions. So all the participants, if there's any question, please send it in the chat. If not, we'll continue as soon as it's ready to go.
Now, if I describe the pod, you can see that the readiness probe is failing. It's been failing 21 times over 52 seconds. This is the probe. This is what it tried to do. It actually tried to access with an HTTP ping, but it couldn't. So it's trying and trying. It will always fail because the pod is not ready yet. So basically, you can see that this replica set, which is the new replica set that I created, will not replace this replica set, which is the two pods that I have here, because it will never be ready. Now let's try to play around a little bit with the liveness probe. Let's say I remove the readiness probe and I put only the liveness probe. Now remember, the liveness actually says when to restart the container. So if the probe fails, the container will restart. So in the test here, by the way, just to recap again, with the readiness, we used an HTTP GET, meaning every time the probe wanted to apply itself, it would send an HTTP GET in port 8080, and it would look for the URI/ping. We wrote some small application that responds with a JSON when you communicate to /ping. For the probe, it doesn't really matter what is returned. It's looking for the HTTP response code, whether it's 200 or 300, it's going to be okay. Anything else, it's going to fail. And this is why it's failing, because it's not ready yet. So I'm going to apply this again. I'm going to put a new version just to redeploy the pod.
Liran, we have a question here.
Sure.
Can we get the Git repository address of this shared example?
Yeah, I can actually, we can put it on GitHub. We have it on our GitLab. And there's also the last office hours here, which is requests and limits. There's a script to build everything and run it. There's no presentation here, but I can quickly write one if you guys will require it. For the liveness and readiness, we'll just put the presentation here, and you guys can play with it a little bit afterwards. So let's see what happened here. In the meantime, it couldn't pull the image. You see that these two pods are now deployed, the backends, but look what's happening here. There's a restart. Let's try and describe this pod. We can see that the liveness probe is failing, and it has been failing for a while. And it says here that the container demo app PE failed Liveness Probe, and it will be restarted. And I can guarantee that these guys will continue restarting over and over and over and over again. Why? Because the failure threshold is 1. The failure threshold is 3. I just put it twice here. We can delete these. It waits for 2 seconds before it starts testing. It has a period of 1 second between tests. The timeout is 1 second, and success, which is it never reaches, is one instance. Once it succeeds, the Liveness Probe will be deemed successful. But once it fails 3 times, the container will restart, and the whole thing will start over again. This is why you can see that these crash loopbacks, it's going to crash, it's going to start again, it's going to crash, it's going to start again. And right now, as you can guess, my backend is completely shut down. I have no way of, it's the same application, nothing changed. Version 15 and 1.15 and 1.16 are basically the same version. I just changed the version numbers to make it deploy the new version. But right now, as it stands, I have no applications. My users are completely disconnected. My website is down. I mean, I have a front end. Other than that, nothing is actually working. If I go back here, I can play a little bit with these guys. Okay, so we said that the failure threshold is 3, and the initial delay in second is 2. What if I put here? I know that my application takes 120 seconds to deploy, so I can change this to wait 2 minutes, 120 seconds, and then it's going to be deployed. Okay, and I can show it to you in a sec. We already deployed the whole thing. But here's the deal. It's going to create another container, right? And this time it's going to wait 120 seconds before it's going to start the probes. So it is in ready state, right? It will not restart the container, but it will stay in not ready state for 120 seconds, and then it's going to start testing. Obviously, we know that the application is actually takes 120 seconds to instantiate the application. So obviously this is going to work eventually. Notice that still both pods are running, still my backend is an error status. Why? Because I don't have a readiness probe. The Liveness Probe is not failing yet. The application is running. Kubernetes thinks that everything is okay. It doesn't have any reason to think otherwise, right? But in fact, what I have as a backend that is not functional yet, it will not restart. It will wait 120 seconds and then start testing the liveness, which will be ready. By that time, the application will already be ready to service connections. The backend status will be back up again. But this is a bad way to do things. The reason is that maybe it takes 120 seconds and maybe the node is very overloaded and it takes some of the times 140, some of the times 90, some of the times 160 seconds. It's very gentle and fragile. Basically, I cannot trust this initial delay in seconds to give me a conclusive or all-inclusive solution to whatever happens to my application. So I'm going to wait a while here just to show you that the backend will be running again eventually, and the pod will not restart. It's going to wait a while, and then basically it's going to start responding. In the meantime, let's talk a little bit about, and you can see that the backend is now okay. Why? Because the application waited oh, it's back not okay again. Maybe it's trying to restart something. Oh, probably the switch between versions. So anyway, this is why we need the startup probe. I don't want to trust a time measurement, which may change or deviate from what I know in my lab, right? This is bias versus variance. In my lab, I tested this application. It took it 120 seconds. Maybe I'm going to deploy it somewhere else, or maybe in a different environment, and it's going to take a little bit more or less. So I can't really trust this number. This is working with a hunch. When I put the startup probe before that, that means that these two probes will not start until this probe is okay. And basically this probe checks that the process is running. This is what we put in a test. This tests, the Liveness probe tests actually that port 8088 is responding to TCP connection. And the last one, in order to be ready, we put inside the application /ping, it responds to /ping. And when it responds to /ping, I know that it's ready to accept connection. So you can see that the combination of these three, sorry, my mouse just, the combination of these three gives me an overall overview, or gives Kubernetes basically an overall overview, very precise as of what's the status of the container and the pod which is running it, when to restart it, when to start sending connections to it. Basically, it allows me to deploy an application and do a rolling deployment without fear. And I'll show you why. Up until now, I showed you how it fails every time I deploy a new version and I omit one of the probes. The backend always failed on us. So now I'm going to put it back to version 16 again, just to redeploy the new version. And let's see what's going on now. Everything is running okay. These two are going to get redeployed with version 116. Right now it's on 115, but the backend status will not be error. And I'll explain why while it's doing this. But you know what? Let's do it before. When I will deploy this new version, what will happen is the startup probe will start testing after 5 seconds within the pod's instantiation. It will start looking for the process that is running. If the process is not running, basically, if this probe fails, these two will be put on hold. So it's going to wait at least 60 failures after the 5 initial seconds in order to start these. And while it fails, it will not run any of them. Only when the startup probe succeeds, then it will start testing these two. So let's try and do it. And it's applied now. Now, what you're going to see again, as I said, the demo BE pods will be terminating. Notice that the backend status is okay. We have a new pod with a new replica set, of course. This is the replica set ID. It's being instantiated, it's being deployed. It is not going to be ready until the readiness probe will succeed. So basically, the startup probe right now prevents the readiness probe from running until it succeeds. So the startup probe is actually my safety mechanism to not restart this pod and not send it any communication before it is ready to accept it and it is running, it's functional. And you can see that the backend status is still in okay. And it's okay because we have 2 pods running right now. But in a second, it's going to delete one of them, but it's not going to delete either one of them until this pod will reach ready state. This is how deployments in Kubernetes work. Basically, when you roll forward a deployment, you have a lot of, I'll show you the definitions. It's a different topic. The deployment will not just delete all pods and create a new pod by default. It will create one pod. Once it's ready, it will delete one of the old ones and then create another one. Once that's ready, it's going to delete one of the old ones. So what you can see here, that it created a new pod. The old ones are still running. Nothing is deleted. Nothing is changed until this guy is ready by the definitions of the probes that I've set. In a couple of seconds, this ready, the 0 here, will be turned to 1. And in that second, one of the old pods will be terminated and another new pod with the same replica set that you see here will be created. And notice why that's happening. In the background, my backend status, meaning my user experience, my users are now surfing the store, and I can actually show you that everything is operational and I can still work. So there's no downtime for users. No one even knows if I'm not showing you what's going on in the background, no one even knows that I'm actually deploying a new version. In a sec, let's see what the status of this pod is. So the startup probe, as expected, failed. 117 seconds. It should start any second now. Let's give it a couple more seconds. I'm gonna get it inside the pod just to see what's going on. I guess it's just a load or something. Oh, I know why. Sorry, I changed this. I told you it takes 120 seconds and I put the failure threshold on 60. I'll redeploy it. What it should do, it's gonna do the same thing, right? Oh, and yeah, it started. Again, I'm gonna put the backend on our screen just to show you guys that the backend is continuously running and everything is okay with the users. It did create another deployment here, basically a replica set with a new pod. It started 29 seconds ago, and let's just let's describe this pod to see when it's going to be ready. And the startup probe failed, 31 seconds. We know it's going to take 120 seconds until the probe is up and running. So it's going to take it something like 40 seconds additional. And you notice that when I mistakenly put 60 seconds here, the startup probe also failed and it restarted everything. It actually tried to do everything all over again. Let's check it again. 70 seconds, 50 seconds more.
Good time for questions. If anyone has any other questions, shoot them over.
Yeah, it's gonna be a couple of seconds more and it should be ready. Once this guy becomes 1 out of 1, it's going to terminate one of these, and then it's going to instantiate another pod. Oh, you see that? Now the new deployment, this one, is ready. Notice that the backend is okay. Throughout this whole process of deploying a new version, users don't feel anything. The backend is still working. They can still continue their purchases. I just deployed a new version. In the background, we have the old version terminating. The new version is already created. This is the second new pod. You can see that the replica set on these two is the same. These are the old pods, but because only one of the new pods is ready, 1 out of 1, and one is not ready, it's terminating only one of the old pods. So basically, only until it finalizes the second one, you can see that I have an old one and 2 new ones, from which only one is ready to accept connections. Throughout this whole time, the backend status is still okay, meaning users can go in and just add products, do whatever they want here, and nothing really happens. So service continuity is what it's about. As I said, in new deployments and making sure actually that pods are running and servicing users correctly. The readiness and liveness probe are not just for new versions, right? What if one of my pods cannot reach the database in the backend? So that pod should not get any requests from users, because if it does get requests from users, it will not be able to reply because there's nothing to query. There's no database in the backend. So that pod should at least not be ready. And in some cases, maybe there's a zombie process inside. Maybe threads are stuck and not responding. Maybe there's a memory leak. Maybe there's a bug. I just need to restart it. So I can tell Kubernetes if this condition or that condition happens. Mainly, I can actually state the conditions like you've seen here. I can state the condition. I can actually say when the test is failed or successful. So what we did here, the /ping is actually one of the tests. I can do /health or /ready or /database connected. And whatever test that I want here, I can put it here and tell Kubernetes that if this test is okay, then the readiness probe, meaning I'm ready to get connections. I can do all the other tests inside my application and just externalize a single URL and say when I'm ready or not. Let's see what's okay. And you can see that the new version is completely deployed. It's going to terminate this pod very, very soon. The backend status is still okay. Everything is still running. We don't have any disturbance to users, basically. And as you can see now, the old version pod is actually terminating. And once it's done, we've completed an application rollout on top of Kubernetes, front end, back end. As you can see, there's 2 of each, so it's highly available, it's redundant. And we deployed a new version, and the users didn't have a clue what happened. This is 100% continuity while deploying new versions. And of course, as I said, even in times of failure, like I can delete one of the nodes on which one of these pods is running, and the second one will be deployed on a new node. But guess what? If I don't have the probes, basically what will happen, that pod on a new node might be ready to accept connection, or at least marked as ready by Kubernetes, when it's actually not. It's going to start, as you've seen before, it's going to instantiate itself. Kubernetes doesn't know any better. So once the container is running, it's going to mark it as ready. That pod is going to start accepting connections. Actually, it's not ready to get them. So we might end up with errors because the backend here, as you've seen before, is in error status. So that was very quick review of liveness, readiness, and startup probes. If anyone has any other questions, any information. And by the way, just to show you how we see it on top of Sosivio, so you can see that we can see states of each and every container. We can actually go into a container and see what the state it was before it stopped. Right now, this pod is terminated, so there's no network connection. It's not going to get us any network connections. But if we go to a live one, then we can see that it's actually up and running and getting connections. You can see that it has 36 connections inside the pod. This is actually, I'm going to show you what this application does. Exactly, it's a demo application, but in order to test this, to make sure that the continuity is service continuity is always there and identified immediately, basically what we're doing is every couple of milliseconds, we do a ping, an HTTP ping to the backend. This is why you see the backend. Okay, once this fails, one of these fails, and I can show it to you. If I will kill both of them. Let's kill both pods, which is something we never do in production, right? Now, both of them are going to die in a second, and you're going to see in my browser, one of them is already dead, second one is dead, and you're going to see these guys get red, and of course the backend status is going to be error. It doesn't happen yet because they're not terminated yet. And of course, Kubernetes created a new one, but remember, it takes time for a new one. But because I killed both of them, then basically it doesn't have an older version to rely on. It started 2 new pods immediately, but they are waiting. And you can see that we did get an error here. And all of our queries are now getting 502. And this is why we get the backend error. But guess what? Once this reaches 120 seconds, Kubernetes will allow it to get new connections. And again, right now, this pod doesn't have any connections. In a second, you're going to see it. You see that it's terminating, it's dead. The new ones are actually running, but they cannot receive any connections yet. This is the pod running, but basically the connections are not transferred to it. This is internal connections. And in a second, one of them will be back on after this, and startup probes are returning true. It's going to start getting us 200 OK again. It takes a little bit of time because the delay for the application intentionally is 120 seconds. And believe me, I've seen applications that take even more than 3 minutes to warm up. Huge applications that do provisioning right. It may not be architected perfectly, but we have to face it. There are applications like that. And some complicated applications actually have to put all the pieces in place before they are ready to actually reply to user interaction. So Adam, I think we're going to finalize with this. We got 10 minutes for, we got 10 minutes.
Awesome. Thank you, Liran. That was wonderful. Thank you all for joining. I see we're light on questions today. I think you did a great job explaining. So good news. We will upload this to our YouTube channel for everyone to share. And we look forward to seeing you. I made a mistake in the very beginning. The next one is not on the 8th. It's actually on the 15th. So 2 weeks from now. And the topic for that session is titled Service Accounts Done Right. Liran, do you want to give a little teaser for that, or we can save it for the invite?
We're going to do a nice little presentation, and it's going to be interesting. A lot of people use service account. Many people don't really use them as they were intended, but we're going to see it next time. I think it's going to be interesting. Let's keep it mysterious a little bit, no?
Yeah. Awesome. So look out for the invite. We'll be sending that through our normal channels. And again, if it's interesting to you and think one of your friends would benefit, please pass it along. This is free for anyone that wants to join. We hope you found it interesting and hopefully you learned something. Real quick, I'll wrap up. Just to introduce Sosivio. Sosivio is an autonomous cloud native platform. You could think of it as next generation observability. So we're a proactive platform, keeping your Kubernetes environments healthy, and we do that non-intrusively. This is not a Sosivio pitch, so I'll leave it at that. You can visit our website at sosiv.io for more information. And thank you all for joining us today, and we'll see you next time.